Data is everywhere in our world. Companies collect vast amounts of it every single day. They gather information on what customers buy. They track website clicks and app usage. They log sensor readings from factory machines. This digital information flows constantly, like a river. It holds incredible potential for understanding and improvement. Many organizations sit on mountains of this valuable resource. They have collected it for years, storing it away carefully. They know it might be important someday. They hope it contains the secrets to their success. But data by itself does not help a business. It is just a collection of raw facts and numbers. Without a plan, it remains silent and unused. Many teams do not know what to do with their data. They lack the skills or the tools to explore it. They miss crucial opportunities to save money. They fail to see patterns that could help them serve customers better. This is a common and costly problem. It is like owning a library full of books written in a language no one can read. The knowledge is there, but it is locked away, inaccessible. This gap between having data and using data is where value is lost. A company might have all the information it needs to prevent customer churn, but if no one analyzes that data, customers will continue to leave. A hospital might have records that could predict disease outbreaks, but without someone to connect the dots, the opportunity is missed. This is the central challenge that a data scientist is hired to solve. Translators, explorers, builders, they turn raw data into meaningful action and tangible business results. A prediction about the future, a better way of doing business every day. The process starts with a question. For example, why are sales dropping in a certain region? A data scientist begins by understanding this question deeply. Then, they hunt for the right data. Sales databases, customer feedback forms, public sources like weather reports. They bring all these pieces together. The goal is to build a complete picture of the situation. Once the data is gathered, the real work begins. The data scientist cleans the data. They find and fix errors. They fill in missing pieces. They make sure it is consistent. Then, they explore it to find interesting trends, charts, graphs. This helps them see patterns not obvious from raw numbers. Finally, they build models, simple rules or complex machine learning algorithms, to make predictions or classify information. The ultimate goal is to turn data into useful answers. A data scientist does not just present numbers. They explain what the numbers mean for the business. They tell a story with the data. For instance, they might find that sales are dropping because of a competitor's new promotion and recommend launching a counter-promotion. In this way, a data scientist connects the technical world of data to real-world outcomes. They are the bridge between information and intelligent action. Let's walk through a concrete example. Imagine an online clothing store. The store wants to recommend the right products to each visitor. This would make shopping easier for customers and increase sales for the store. The store has lots of data. Every purchase, what customers looked at, and product info like color, style, and price. This is the raw material for a solution. A data scientist is brought in to tackle this challenge. Their first step is to get the data ready. Real-world data is almost always messy. There might be wrong prices, missing product descriptions. The data scientist cleans it, writing code to correct errors and handle missing information. This cleaning process is not glamorous, but essential. A model built on messy data gives incorrect answers, worse than no answer at all. After cleaning, exploration begins. Do people who buy black shoes also buy black belts, summer dresses and sandals? These insights suggest important features. Perhaps brand preference predicts future purchases. Finally, they build and test a model. Start simple with most popular, then a more complex model that learns from purchase histories and finds shoppers with similar tastes. It recommends items similar people bought. They test it. Precision, recall, user feedback. Then integrate it into the website for personalized recommendations. A data scientist uses a variety of powerful tools to do their job. These tools help at every stage, from collecting data to presenting the final results. Programming languages are fundamental. Many data scientists use Python and R. These languages have special libraries made for data work. Pandas is great for cleaning and organizing data tables. Scikit-learn provides many ready-to-use machine learning models. Getting the data is key. Most company data lives in databases. A data scientist needs to talk to these databases. They often use SQL, SQL lets them retrieve the exact data they need. They also use tools for exploring data and communicating findings, like Matplotlib, Seaborn, and Tableau. However, tools aren't the most important part. Knowing a hammer and saw doesn't make a master carpenter, and the same is true in data science. Good judgment matters more. Great data scientists ask the right questions, are curious, think critically, and consider whether a model fits the business problem. The human element is critical. Data science is a team sport. They work closely with business experts, marketing managers, product experts, engineers. The best data scientists are great communicators. They listen carefully to business needs and explain complex results in simple, clear words. The combination of technical skill and human connection is what creates real value. Data scientists are in high demand across nearly every industry you can imagine because almost every business collects data. Wherever there is data, there is an opportunity to use it to make better decisions. Problems differ, but the core process remains the same. This versatility makes data science exciting and dynamic, and impactful for society. In retail and e-commerce, they build recommendation engines and forecast demand, preventing stockouts and reducing waste from over-ordering. In finance, they detect fraudulent transactions in real time, protecting customers and institutions, and assess credit risk for loans. In healthcare, they analyze clinical trial data and build models to help doctors diagnose diseases earlier and more accurately. In telecom, they predict churn, so companies can make proactive offers, often much cheaper than acquiring new customers. In manufacturing and logistics, they predict equipment failures to prevent downtime and optimize delivery routes to save time and fuel. Across domains, the pattern holds. Identify the problem, gather relevant data, build a model, and measure impact. The applications are endless. Within the broader world of data, you will often hear about an applied scientist or AI/ML specialist, closely related to a data scientist but different in focus. Data scientists often apply existing tools to business problems. Applied scientists build new, advanced models and algorithms at the cutting edge of AI and ML. An applied scientist often works on novel, complex problems, requiring deeper mathematics, statistics, and computer science. While a data scientist might use a standard library for churn prediction, an applied scientist might create a brand new algorithm for understanding human speech. They may develop core technology for assistants like Alexa or Siri, often inventing techniques or adapting research papers into practical applications. Think of it this way. A data scientist is the expert builder using the best tools. An applied scientist is the engineer inventing new power tools, faster saws, more precise drills. Both roles are valuable and collaborate. Research prototypes are handed to data science teams who apply them to business features like better product search or auto-tagging photos. The applied scientist pushes technology forward, while the data scientist makes it useful and impactful for the business and its customers. Proof is what truly matters in business. Ideas and models are interesting, but measurable results convince people to invest. Here is a simple but powerful example. A large grocery chain was throwing away huge amounts of fresh produce every week, costing millions. It was hard to predict how much to order for each store. The company formed a data science team to build a demand forecasting model. They collected years of historical sales for every item in every store and added factors like day of week, promotions, and local weather. People buy more soup on cold, rainy days, and more watermelon on hot, sunny days. The team cleaned and prepared the data, then built a machine learning model to predict daily demand per product per store. The model learned complex patterns, how promotions, holidays, and weather interact to affect demand. They tested rigorously with backtesting, tuned parameters, and raised accuracy. The chain rolled out the model to inventory systems. Store managers used daily predictions to place produce orders. Results were immediate. Food waste fell by over 20%, saving significant money. Shelves were fresher, and items were in stock more consistently. This is proof of value, taking a real business problem, applying a smart solution, and delivering clear, positive results. Data scientists unlock the insights hidden within data. Applied scientists push the frontier. Together, they turn information into intelligent action. In any industry, retail, finance, telecom, healthcare, manufacturing, their work transforms messy data into decisions, predictions, and measurable impact. If you harness your data with purpose, the results speak for themselves.